Hello everyone. In this video I want to talk about three paradoxes leading to the invention of quantum mechanics. At the end of 19th century, at the beginning of the 20th century, people were thinking that the electron and other fundamental particles has a definition of being localized and having some properties such as momentum and energy. On the other hand, the electromagnetic waves are extended objects and they are defined into the space and time, and they carry energy and momentum too. This idea of particle perhaps is coming from a soccer ball, or when we are looking at planets and stars from far distance, we see them as point-like objects, or when we are looking at the dust particle, we see them as particles. In Newtonian mechanics, you can show a rigid body behaves like a zero-dimensional particle at the center of mass when we are exerting force on it. So it was convincing to think about smaller objects being more uniform and being similar to point-like objects. Now the question is, what is a field? Each charged particle creates a field around it, and if we have a positive and negative charges, they exert force on each other because they create a field on a space around them. If we have so many charges in one area, the total electric field is the summation of each individual electric field. It is because electromagnetism is a linear theory, and we see that it is not the case for other theories such as the strong force. This visualization is just electrostatic. That means that the electric field doesn't change with time, so we don't have any magnetic field. In a more realistic case, we see an electromagnetic wave. In this visualization, you can see a linear polarized electromagnetic wave is coming, and the charged particle such as electron is somehow constrained on the z-axis, and it is acting like a harmonic oscillator, and it is responding to the electromagnetic wave that it is crossing by. You can see other types of polarization such as circular polarization creates a different motion for the charged particle, and this is the underlying function of the antenna. When different types of acceleration of the charged particle can create a specific radio transmission wave. Now let's talk about the challenges that come along when we assume matter is particle and radiation is wave. Before we get into the electron in atom, let's talk about Vermeer-Long radiation. It is not really possible to think about any orbital motion of the electron around the proton or the nuclei, because in electrodynamics, any charged particle that goes under deceleration experiences a drag force by the electric field around it and loses energy. By losing energy, the electron eventually falls into the nuclei or the proton, and it is not really clear why the atoms are stable. That was a disaster because at that time they could not explain the similar motion of the planets and sun into the atom. BlackBody anomaly happened when we tried to mix Boltzmann statistic and classical electrodynamic. To make an abstract picture of the BlackBody, we can think of it as a cavity that a standing electromagnetic wave exists on it, and we can write down partition function and calculate the average energy per unit of the frequency. To better understand the relationship between energy and frequency and amplitude, consider this example. Imagine there are high frequency and low frequency waves with the same amplitude. If they hit a simple harmonic oscillator in the same amount of time, the energy transformed by high frequency is more, but if we normalize it to the period of each wavelength, then we realize this energy is only proportional to amplitude. If we write down the energy as the summation of independent degrees of the freedom, we can calculate the partition function easy. If the dependency on the variable is quadratic term, then the partition function is straightforward. Here we just have to replace x with the amplitude of the electric field. So we replace this x with the amplitude of the electric field, and this is the variable that we need to integrate it over the partition function. So we can rewrite this same integral for the energy of the standing electromagnetic wave in certain frequency. And the result is the function of temperature and other constant of the problem. Remember, we already talked about averaging over time because of the frequency dependency. The Hamiltonian is proportional to a sine function, but we said for thermal equilibrium and time we need to integrate it over time and normalize it to the period of that specific frequency. So that leaves the energy to be only dependent on the amplitude in the quadratic term, because the average of the sine 2 function is 1 over 2. So surprisingly, the energy is independent of the frequency and amplitude inside of the blackbody radiation, and the average of each mode of frequency is kT, similar to equipartition theorem in particles. It led into ultraviolet catastrophe discovered by John Stroud, known as Rayleigh-Jeans relationship, which puts no limit on very small wavelength to carry the energy. The photoelectric anomaly completes the previous problem. To summarize the photoelectric anomaly, imagine that you want to eject some electron from the surface of the metal, and you try to use high frequency light and low frequency light to see how the energy of the electron changes by the frequency. And you can see for the low frequency light, it doesn't matter what's the amplitude. High amplitude and low amplitude are the same. And you can see that there is a certain threshold of frequency that you can eject the electron out. So no electron comes out from the green light even though we increase the amplitude. So energy at the absorption level is proportional to frequency. For the summary, first, the idea of particle is highly motivated by macroscopic world. And we realize that in the microscopic world this is not the case. In the atom anomaly, we realize field particle picture cannot explain any orbital motion of electron around the proton. And in the blackbody anomaly, we realize that there is no limit of how much energy a smaller wavelength can carry. In photoelectric anomaly, we realize the energy of light absorption does not depend on the amplitude of the light or its intensity, but on the frequency of light. That means light is similar to a particle. A particle has 1 degree to carry the energy, which is the momentum, and light also have 1 degree to carry the energy, which is the frequency. And later on, we realize momentum and frequency are kind of the same thing.